Okay, so in this seventh session, we are going to learn about two topics. Okay, one is vertical earthquake loading. Okay, vertical earthquake loading. Okay, this one as per SC 705, and this one as per BNBC 2020. Okay, both yields same value. Okay, only the difference is the expression of their equation. Okay, so SC 705 and BNBC 2020 explicitly says that vertical earthquake loading must be included in your FEM model. Okay, so actually this vertical component of earthquake loading, okay, is associated with your load combination. Okay, load combination. Okay, so in next class, when we will learn about load combination, we will know how to associate vertical earthquake loading to the load combination. Okay, so if I go from BNBC 2020, I can see there is the equation. I just write the equation 0.50. Okay, AH mean 2/3 ZS, okay, into D. D is dead load. Okay, so what is the value? 2/3 Z 0.2 into S 1.35 D. So this will give a value of 0.9 D. Okay, this is as per BNBC 2020. Okay, if we follow this equation, then what we get? 0.2, okay, SDS into D. Okay, so 0.2, we know SDS mean 2/3, okay, into SMS into D. Again 0.2, okay, 2/3. SMS mean FA into SS into D. Okay, so 0.2, 2/3. We know our FA was 1.35. We have applied in earthquake definition, and SS was 0.5 into D, and we get 0.09 D. You can see this value and this value is same. Okay, and this is SC code. Okay, so we need to apply this additional load. Okay, this is called vertical earthquake loading. Okay, so this additional load, okay, this additional load need to be applied with our load combination. How we are going to do this? We are going to see this in our next session. Okay, so this is an important issue. Okay, this is an important topic because earlier, in ASC code, there was no vertical, seismic load effect. But in recent codes, they have included this one. Okay, so this needs to be applied with your load combination. So we are going to learn our load combination in next session. So before that, we need to understand what is vertical earthquake loading and what is the value. Okay, 0.09. We will remind it, okay, in our next class. So how it will be incorporated with load combination, we'll see in the next session. Okay, so this is an important topic. Okay, This is an important topic. Okay. Now, another topic is important. This is also associated with load combination. Okay. This one is, notional load. Okay. This one is notional load. So what is notional load? Okay. Normally, we design our columns straight, right? In straight, okay, straight. Okay, straight. But during erection of our column or for any reason, the column may deviate. Okay, the column may deviate, up to a certain distance. Okay, this is called initial plumpness. Okay, what is called? This is called initial imperfection. Okay, though we are designing our column as straight, but during erection or some other reasons, the column may not be straight. That is called out of plumpness or imperfection. Okay, so to account for this initial imperfection or out of plumpness, okay, AISC code tells you to incorporate a load. Which code tells you? AISC. Remember that. AISC tells you to incorporate notional load to account for this initial imperfection or out of plumpness. Okay. So actually the notional load, actually it is a lateral load. Okay. This is actually a lateral load. And what is the equation? The equation is 0.002 yi. Okay. So what is yi? Yi is the gravity load from LRFD load combination or 1.5 times the ASD load combination. Okay. We are designing our, this shed considering LRFD, okay, method. Okay. So, yi, software will automatically calculate this one. No problem. Okay. So, yi, this value will be calculated by software. Okay. So, before going to our model, we need to know 2 or 3 things. So why we need notional load? Because of initial imperfection or out of plumpness. Okay. Here, this notional load will be added to the load combinations. Okay. For simplicity to all load combinations, this notional load will be added. But there is, some exception. So what is the exception? Come here. Okay. You can see here, if the second order drift, okay, to the first order drift is equal to or less than 1.5. Okay. If we get a drift ratio of second order and first order, which is 1.5, then it is permissible to apply this notional load to only gravity load combination. Okay. That means if the ratio is 1.5 or less, okay, then this notional load should be or must be applied to the load combination that have only gravity load. Okay. Not in combination with the lateral load. Okay. Secondly, if tau b equal to 1, what is tau b? We need to wait for another session. We will learn this in our direct analysis method class. Okay, you have to wait for 1 or 2 class, okay, to know about direct analysis method. So this tau b comes from direct analysis method. So if tau b equal to 1, then this notional load will be, like 0.003 yi, and additional 0.00 yi will be added to 0.00 yi, and that will be equal to 0.003 i. Okay. Another one is for gravity load combination. Okay. So how we are going to apply this notional load? Okay. For gravity load, okay, for gravity load, you can see this example. Look at here. There is no lateral load, only dead load and live load. Okay. So if this notional load is added to the gravity load combination, then notional load should be added to both direction, added to, note that, added to both direction with plus and minus. Okay, look, remember it. I will show you in load combination. Don't worry about that. Okay, for load combination with lateral load, if notional load is added with the lateral loads, then how they will be added? Look at here: 1.2 deadlock, 1.6 live load. Here is minus 1.3x. Okay, here minus is the direction, okay, along negative x direction. So your notional load will be also in that same direction, minus x, okay, along x direction, because this will create a severe impact on the structure. That's why it says for load combination with lateral with lateral load must be applied in the direction that adds to the effects of the lateral loads. That means you have to apply in a certain direction that's that actually have a great impact on the structure. So if here we can see our wind load is acting along negative x direction, so our notional load will also be added along x direction and along negative x direction. Okay, clear? So you have to look for both gravity load and also for lateral load. For gravity load, notional load will be added in a way. On the other hand, with lateral load, notional load will be added in a on the other way. Okay, so you have to be careful. Another one is no national load is required for serviceability. For drift, deflection, vibration, or any other serviceability, you don't have to apply for your notional load. Okay. Okay, so these are the things we have to remember, for notional load. Okay, so both notional load and vertical earthquake loading will be added with our load combination. Okay, so now we go to our model. Okay, here we can see this is our model. Okay, now we can go to here, then add. Okay, we can provide a loading type. Actually, notional load is a kind of imperfection. Okay, so just put imperfection. So for notional load, for n for notional load, okay, dead, okay, along x direction. Okay, just put it there. I just keep a copy, add again v, again z direction. Okay, along x and z. For Stadd Pro and for ETAPS, it will be x and y. Okay, add. Now Control V. You can provide for live. You have two live load. You can provide one live for for LLF. Okay, for LLF, copy, add again, and this is for roof. Okay, for sorry. Okay, same thing. Okay, so along z direction. Okay, and again we just this time it is live. Okay, x direction, make a copy and then paste it here again along z direction. Okay, so our notional load cases are done. Okay, so go here, add, go to repeat load. You can see notional load. Okay, you have to it is dead load, okay, along x direction. So just put dead. Okay, so you can see factor 0.002. We have also seen here. Okay, we have also seen here. This is the factor. Here you can see. This is a factor. Okay, 0.002. Okay, and yi. Okay, this term will be calculated by software. Okay, so go there. You can see. Okay, and just add it. Okay, close. Just go there. Just go to repeat load. Okay, notional load. Again, dead load. Your factor is same, but this time direction will be z. Just add there. Okay. Now go there. This is floor loading. Though we don't have any floor loading, but we will assign, no problem. Okay. Notional load. Here you can see your floor loading. Okay. Floor loading. This is x direction. Okay. Again, go there. Go there. Add. Repeat load. Notional load. You can see floor there. Okay. This is along z direction. Okay. Add. And now live load of roof, which is important for our model, for in this case. Okay, now roof there, x direction. Okay, go there, add repeat load, notional load, and roof. Okay, z direction. Okay. So our notional load cases are defined. Okay, now we will add this with our load combination. Okay, so in next class or in next session, okay, we will learn how to add this notional load cases and earthquake load component to our load combination. Okay, so thank you for watching and stay tuned for next session. Okay, thank you.